scikit-learn. There's some hype in there, so I will do a little bit of explaining about what machine learning is, if you're not familiar with that. Hopefully explain what it is and what it isn't. In production, that is slightly a lie. This talk is about a project that was supposed to be in production at this point in time when I committed to doing this several months ago. We've done a lot of the work to get it there, but take with a slight grain of salt in that I won't actually be able to talk about the learnings of, as this thing has scaled up so far. But we will be using scikit-learn. I am a data engineer at Simple. I will tell you a little bit more about what Simple is. First, a little bit more background on me. I am Jeff Klukas. I came to technology through science. So I went to grad school at the University of Wisconsin-Madison. I worked on the Large Hadron Collider, which is really fun. This is me in the cavern of the CMS experiment in Switzerland, about 100 meters underground. So why do I mention this? Since I now work at a tech company, I mention it probably because it's just cool. It was a fun. It was a pretty fun project to work on. I also mention it because when you think of machine learning, you often think of big data. And this was a project that was definitely big data. Like when this thing is running, there are collisions happening every 25 nanoseconds. Like each one's like a megabyte. It ends up being a huge amount of data. There's like all this cool trigger system to like get down to a manageable size, and you still end up with petabytes of data. So like petabytes, 1,000 gigabytes is a terabyte, 1,000 terabytes is a petabyte. Then you have like hundreds of petabytes of data sitting on a disk somewhere, and you're doing distributed stuff to process it. So I got to do that in grad school. Never once did I do any machine learning in grad school. So huge data sets, no machine learning. Why? Some people did use machine learning in that realm, but it's kind of something you only resort to if you have to, because in research, like you want your results to be interpretable. You want to be able to explain what's going on. So, I mean, I'm kind of proud of that we really did, I feel like, do a good job of relying on. If you can make a plot and say, I cut out everything below this line on this plot, that is understandable. And, like, those were the kinds of papers that we were writing. So lots of data, but, making these very, like, interpretable things. On top of it, with machine learning, you're kind of handing data over to a black box. And then you say, like, what did it do in that black box? And you can talk about algorithms, and you can talk about linear algebra, but there's a lot more context you need to know, and in the end, there are a lot of details that are harder to reproduce. So these are reasons why you might not want to use machine learning for a problem. And what I'm talking about today is going to be machine learning on a very small data set, which is a couple of gigabytes. This was big data, no machine learning. Today we're talking about machine learning without big data. And there are good reasons to do that or not to do that, and hopefully you'll leave this with a little bit better understanding of why you might want to or not use machine learning for your problem. So a bit of an overview of the story today. Talk more about the problem that we're solving. In our case, it's about classifying text chats. We'll talk about that question of why did we use machine learning for this problem? Why might we not want to use it for this problem? We will walk through steps of developing the model. So you'll get to actually see a bunch of Python code showing you what it looks like to interact with scikit-learn. And it turns out that humans love live demos and seeing things actually happen. So you humans will be able to experience that rather than just seeing slides and believing me. Then we'll talk through some complications of this. Okay, so you've built this kind of toy model, you've proved that it can work, and then you actually want to run this thing in production and do useful things with it. And what gets complicated about that? How do you manage that whole life cycle of creating a model and using it? Then lastly, we'll talk about if you think that what we did in here is garbage, how else might you decide to do this if you want to do machine learning? And there are lots of different reasons why, like the shape of your organization and your team and your problem are likely not going to be exactly what is shown here. So other approaches might work for you. So what is the problem that we're solving? A little bit of context. This is simple. It's the whole idea of banking remade with lovely design, equally lovely tools to help you save right inside your account, and genuine human goodness. I'm going to actually be focusing on this genuine human goodness part, which largely talks about Our customer relations, a big piece of what makes Simple different from some other bank is we have a fantastic customer relations department, which all works at our headquarters in Portland, Oregon. That's about half of the company is customer relations. And they're great people, and the problem we're talking about today is about making their lives easier. So I work for Simple. I'm remote, actually. I live in the Columbus area. I'm the only one in Ohio, so I was actually in Portland last week, and I'm glad to be back. Categorizing chats. So our customer relations department, the primary way that they end up interacting with customers is through, in the app, you can send a support message or a chat. And then a customer relations agent gets to respond to that and be pleasant, and oftentimes send you a GIF in the response. That data all makes it into our data warehouse. So what you're seeing right here is a fictionalized query somewhat to our data warehouse. Amazon Reddit is what we use there. So it's a database. You can run a query against it, and you can look at a bunch of this chat data. So chats have a subject and a body when you initially submit them. And after you submit a chat, there is somebody in customer relations who's assigned to looking at the queue and triaging chats, assigning them categories so that they can go to different people who are specialized in different things. So one of those categories you see here is urgent. If you lose a card, it's something that's exposing you to fraud. It's exposing us to fraud. We want to deal with that as fast as we possibly can. So that's part of the reason of triage, is that hopefully we can find these really important things quickly and then make sure that somebody is assigned to it. So these are kind of the categories that you might assign: urgent, customer education, a new product, incidents, other things. So this is a great situation for machine learning, in that we have this data warehouse, we have this data set with hundreds of thousands of chat messages that we can go take a look at, and we can have a machine come look at this stuff. And basically what we've got here, subject and body, these are kind of the question, and then category is the answer that we want to get out. So the problem that we want to do is we want to do the categorization thing automatically. We want a machine to handle this so that a human doesn't have to. And we already have this large corpus, this large set of data where we have a recorded answer. Like, a human has already tagged these things, and we can use this as a training data set for figuring out if some approach we have works or does not work. So luckily, we don't have to, spin up Mechanical Turk and give our customer information to a bunch of random people that go on Mechanical Turk. Just to be a little bit more explicit about what this looks like, this is in our web app. This is a case where me, Jeff, actually lost my card in St. Louis, and I sent a message. And this is basically what we're talking about here. So you might have this whole long chat with an agent, but it's just this initial contact where I say, hey, I lost my card, and the subject on this was lost card. We want to categorize this thing so we can figure out who to send it to get the chat started. These are some of the lovely customer relations people that we have. They are smart, empathetic people, and we don't want them to have to spend their time sitting and just reading through chats to categorize them. We want them to be using their empathy to actually respond to issues. So how do we approach this problem? Obviously, we want to use machine learning because it's got sparkles and hearts, and big companies use it, and it makes you feel warm and cuddly and smart. Those are bad reasons to use machine learning. Like I said before, you do sacrifice a lot of interpretability. So if I tell you that I want to use machine learning with this problem, your first question might be, couldn't we do something else? And you can imagine things we could do. We could write some simple rules of, like, we just have like an if the subject contains lost card, maybe this is something we want to treat urgently. And you could imagine totally solving this and just like having kind of a list of rules that some human is coming up with. And that would be a great first pass. See if that works for you. If that works, then please do that instead of doing machine learning. There are a couple of reasons why you might want to do this. If you try to do that, but like there's still a whole lot of cases that you aren't catching, there's a good chance that machine learning is going to allow you to get farther in terms of optimizing the accuracy and scope of that. It can get very hairy to maintain a rule set like that. In our case, we have a data science department that wants to own that, like figuring out how do we categorize chats, and then we have engineering that is actually taking those rules and putting them into production. And we've had a couple of cases where we've tried to do some simple rules, and it ended up being very difficult to like keep that communication going of like, do the data scientists like go in and change the service code? And machine learning, one of the nice things is that you can create a model artifact that then is something that's very easy for engineers to say, then like take that artifact and put it in, and kind of this thing that data scientists can create something that gets plugged into another service. In our case, we get to use a bunch of natural language processing techniques, which like this is a whole field of research, and it's something that Scikit-learn, for example, has great support for. So one reason going down this path was nice is that you get to piggyback on a lot of these things that are already existing for the kind of problem that we want to look at. And management wanted us to use machine learning. And that's something, there is some validity in that like our data science organization has greater ambitions as to like the ways that they want to do this, and we want to take a small, understandable question to really prove what this whole workflow looks like. So implementing this is hopefully the first step towards having infrastructure to be able to tackle other problems with machine learning in the future and do exciting new things. So if you are in my shoes and you are an engineer who has never implemented a machine learning problem, and you're talking to data scientists and like, we want to do this in Python, we think, and we're using some scikit-learn, what would you do? You would go to the scikit-learn documentation and you would try to figure out what on earth is going on. So this is, I'm going to kind of walk through my journey of understanding stuff. So scikit-learn's documentation, it's pretty great. There's some good stuff in there. I recommend you check it out. So if you go to the front page, you go up to the documentation tab, you'll get to the user guide, and it's actually got this really fantastic just first paragraph section about what even is machine learning. So I'm just going to give you a little bit of a highlight here. It says a machine learning problem consists of a set of n samples of data, and then it considers a set of n samples of data and then tries to predict properties of unknown data. Okay. If each sample is a singular number and, for instance, a multi-dimensional entry, it is said to have several attributes or features. So in our case, we have a data set with two features. There's a body of the message and there's a subject on the message. So we have two features to feed in, and then we want to get some answer out of a classification. There are generally two types of machine learning problems. There's supervised learning and there's unsupervised learning. Unsupervised learning is in the case where you don't have the answers already. So if you didn't have them already classified, this is things like clustering. So you could imagine like taking all of those chats and just saying like, hey, algorithm, try to figure out some things that look similar to each other. And maybe that would be useful for even getting a sense of what categories I want to have. And you could like take a look at those clusters. What's in common with those? Oh, it looks like lost card things are a category that I might want to consider. That's not what we're doing. We are doing supervised learning, and in particular, we're doing classification. So we already have a data set where we have some inputs, and what should the classification be? We're going to learn we're going to train on that data set, and then we are going to spit out a model that's able to take in new inputs and predict a classification for it. Okay, now we get into the fun stuff, the code. This first slide kind of lays out the whole thing, so be prepared. We're jumping into scikit-learn. In particular, we are creating a pipeline. So this is one of my favorite things about scikit-learn is it has this whole API with lots of bits and pieces, but it provides this nice kind of wrapper of you can define a pipeline with a whole bunch of steps of how do I want to process my data, and then finally apply a classifier to it. And this ends up making our job of taking all of this stuff and turning it into an artifact a lot easier down the line. So this slide serves as an introduction to scikit-learn. It serves as an introduction to natural language processing. So I'm going to go through each line a little bit here. So creating a pipeline. First step in here, we're giving it a name. We're calling this step preprocess. And then we're passing in this message preprocessor. So message preprocessor and text processor. In our case, these are two classes that we have defined, but they inherit from this scikit-learn interface of a transformer mix-in. So it gives you this way of, you just instantiate a class that's based on this mix-in, and it becomes something that you can throw into a pipeline. So the message preprocessor, all of that is doing is it's taking in some chunk of data that has a subject and a body in it, and it's turning it into a single string, and it has the subject weight in here. So the subject weight is simply include the subject that many times. So we found that the subject tends to be more important than the stuff that's in the body. So this gives us a way to kind of dial up how important should the subject be. So we just duplicate the subject a bunch of times, append that to the body, and that's the output of this preprocess step. So now we're just down to a string. Then we use this text processor. It takes in stop words and a lematizer. So stop words, this is a concept from natural language processing. These are things like and, as, but, just like all of those words that don't really add information. They're just kind of connecting together the sentence. So this is something you might want to play around with. We might want to include simple, simple.com, other things that are like specific to our domain that really aren't adding information to the message. And then a lematizer. So this is another natural language processing term. A lemma is the form of a word that you would find in a dictionary. So if you think of stopping, the word that you would look up is stop. So a lematizer is just a chunk of code that will take in a bunch of words and change stopping into stop, change going into go, etc. So this is some of those like pre-canned techniques that you can take advantage of. You can find lots of documentation on that. So this is cleaning it up. Next step is a count vectorizer and this term frequency transformer. These are just progressively going away from, like, we had text at this point, and now we're just kind of creating this mathematical glob that is easier for an algorithm to understand. So I'm not going to go into what those things are specifically. And then finally, now that we have this nice mathematical form of the data, we've turned it into this count of words, and it's transformed. Then we throw it into this classifier. It's a gradient-boosted classifier. Don't ask me about the specifics of gradient-boosted classifiers. One of the data scientists chose this. Okay, so this is the whole pipeline. All the steps that our data is going to go through. Yeah, question. Correct. Yeah. Great question. So one of the great things about scikit-learn is that it has become this. It's kind of a cornerstone of if you want to do machine learning in Python, but it doesn't have to stand on its own. And a lot of other packages, provide wrappers that make it easy to plug things into scikit-learn. So, yes, XGBoost is a separate package, but it provides a nice wrapper, and you can just throw it into a scikit-learn pipeline like this. And feel free to ask questions as we go through. Any other questions at the moment? It does come with its own classifiers. Yep.
How are you passing stuff from
How? So, yeah, this pipeline object gets, this is literally a list that we're passing in here to the pipeline object. So it holds all this stuff, and then you'll see in the next slide, like how we pass data into this whole thing. Yeah, one last question here.
Quick question about scikit-learn.
Yep.
Is it based in part on the natural language toolkit, or does it have its own implementation of that kind of functionality?
Is natural language toolkit a specific library? Oh, NLTK, is that what that is? I have no idea the overlap there. I think that we are using NLTK in some of the stuff that we were doing here. I can't remember the specifics of whether, what's built in and what's not. All right. So we have a pipeline. Let's actually do something with it. So the first thing that we have to do is we have to train the model with existing data. So this gets into a little bit of, if you've never heard of Pandas, it's part of the Python ecosystem. Just quick introduction to Python ecosystem. There's NumPy, which is a library that's just like efficient arrays and stuff, kind of like basic building blocks. There's SciPy, which is a bunch of algorithms that are useful. And Pandas is kind of like data science glue stuff that makes things convenient. So Pandas has this read SQL function. You just pass it in a database connection and a query, and it spits out something that's called a Pandas data frame. And it's basically it's a big matrix of information with a bunch of convenience functions. So we're pulling all this data out of our data warehouse, the category, subject, and body, and then we're breaking it up into y is the dependent variable. This is the thing that we want to figure out, the category, and then x is the independent variables, the subject and the body. Anything about this line rub you wrong? Anything that seems non-idiomatic about this line? Somebody want to call it out? This is a capital X over here. Why on earth is this a capital X? This should be a lowercase x because it's it's a variable in Python. It's a capital X. This is a case of kind of math idiom trumping Python idiom. So in linear algebra, in math in general, like this is a matrix. Yeah, this is a single. This is a one-dimensional thing. This is a multi-dimensional thing. So that's why you'll see these x's be capitalized. Okay, so we break it up, and then we break it up even more. What on earth is going on here? Train, test, split. We are essentially saying we want to reserve 1/3 of the data for testing later, and we're only going to train this model on 2/3 of the data. Why would you want to do that? The more data that you have to train, the more accurate your model can potentially be. This I will explain in a little bit why you want to reserve this, but that's what we're doing. We're reserving 1/3 of the information for testing later. Finally, we call pipeline.fit, and we pass in all of this information, this training data set in there. So we're telling it that that X stuff, those independent variables, and we're also telling it these are the answers that we've already created. So once you've done that, you want to go back and you want to use this test data to validate how is it performing. And why do you need to validate? Because there's something called overfitting. So imagine that these black points are some sort of data that you're interested in. You could fit that with this black line here, a nice straight line. You'll notice that doesn't pass through the points, so there's some error there. It's not perfectly modeling the data. But generally, the black dots tend to be in the lower left corner, and they tend to be in the upper right corner. This black line is telling you something about the underlying structure. This blue line perfectly fits the data. It hits every point. But if I take some more observations, do you think that they are going to fall perfectly on that blue line? Probably not. This blue line tells you absolutely nothing about the underlying structure of the data. So this is overfitting. This blue line is like you have extracted too much out of your training data set, and it's just gibberish. It doesn't really tell you anything about predicting future results. So that's why you want to reserve some, so you can tell, have I overfit? Would this be able to make reasonable predictions for future inputs? So testing the model looks like this. We have our x-test matrix here. We're throwing it into this predict method of the pipeline. So that spits out what the model says the answers should be for this test data. And then we're printing out this classification report that considers what the model predicted, and then what were the actual assignments that the humans made to this. It does some statisticky things, and then it spits out, this is generally how you are performing. We aren't going to go into the statistics of this, and this is bogus and does not actually reflect the data that was thrown in there. But that's the kind of thing you can get out. This score is kind of basically telling you, if this were a 1, it means like you always got it, your model's doing great. If this is lower, it's giving you a sense of kind of what maximum performance you can expect for future inputs. So we've actually trained the model. We've put some information through the pipeline. So we have a model that we can use. And now, in order to put that into some context where it can be used in the future, we want to actually wrap that in a Flask service. So this is what it looks like to actually be able to spit out classifications in an API using Flask. So we are defining a route. So we're going to have a service that you can hit a URL that looks like this. This is a messages endpoint. You post JSON data here. You pull messages out of that JSON. Then we're calling this pipeline.predict method again. This is the same thing that we called in testing. And then we're just massaging the data out of those predictions and JSONifying it again for something that we can spit back to the user that requested. We'll get to that. We'll get to that. Asking about pickling and persisting model. OK, so live demo time. This is exciting because it means that I can mess up all sorts of things. So over on the right here, we're going to actually start up this Flask app. It's bundled up in this bin run executable that we created. So this is now running. We have a Flask app going. And you'll see this spit out log messages as we make requests. So let's try to hit this API. We get 405. That's because we said that this should be a post. So we just made a get request. It returned a 405 because we didn't tell it what to do with the get request. So let's make this a post instead. So -x post. I'm using curl, which is the command line thing for making HTTP requests. Got 400 this time, getting a little bit better. So we're making a post request now, but we aren't actually posting any data. So we need to actually give it, what data are we trying to post? So let's actually put in a whole message here. So you can just ignore these two IDs. This is just for like tracking, so that when you're making a request, you can understand what is the message that I'm getting back. But we're putting in a body and a subject here, and this thing is actually running, and we're going to see what classification it makes for this message. Do you like that class label? It correctly classified as urgent. Good job. So let's make another request here. Let's say instead of this, I am interested in some new feature. So let's see, joint accounts. I want to ask about joint accounts. And I'm going to put in my body here. I want to share money with my bae. All right, that ended up in customer education. I think that yeah. If you choose slightly different, then I want to share, let me see, share an account. Yeah, OK. I got this to say new product earlier. So you can tell here, this is not perfect. There was not like material difference between those two. So it identified, so shared accounts were like a big new thing that we launched in January. We didn't have joint accounts for a long time, so people were very excited about this. But that was a new product. All right, anybody want to volunteer information for one last request, and we'll see what it does.
I'm curious if your first one,
yeah.
If you change lost to found, what it does.
That's a good question. Let's see, I found my card. Yeah, I mean, there's the lost card thing up there.
Wait,
I found. Yeah, it might still. The ASAP part may mark this as urgent. So interesting.
The exclamation marks doing that?
They may. I don't remember whether we. I don't remember whether we strip out punctuation. We may strip out punctuation, but I'm looking for a volunteer to put something else into this before we move on.
What kind of card protection do you offer?
Okay, what kind of card protection? I will say protection. Protection. Ooh, what kind do you offer? What kind do you offer? Kind people. Yeah, customer education. A lot of these end up getting labeled customer education, which I think shows that we have a lot of things that we tag customer education in our input. So I am running lower on time, so I'm going to keep on chugging, and I'm going to go back to the slides. So great, we have a toy. All right, all right. So we have a nice toy. It doesn't work perfectly, but it does. It's better than not having any classification at all at this point. So we put it in a web app kind of shape. How do we actually take this to production and allow our data scientists to do their thing and create models and allow this to actually get into this application? This was supposed to be. Oh yeah, okay. I was supposed to say something about the training wheels coming off. Anyways, so some things that you might want to consider. I'm going to talk about like 3 steps of stuff that we did to turn this into something more sustainable. So the first step of real life here is separating training the model and actually serving the model. Again, this is kind of like data scientists want to control training the model. Engineers care about serving the model. The one is kind of a batch-oriented thing. The other thing is something we want to serve in real time in a service. So to do that, we need to persist the model somewhere and have it, someplace where the service can then pick it up. And somebody asked the question of, did you use Pickle to do this? Unfortunately, yes. Yes, we did. And why did we do that? Because if you look in the documentation for Scikit-learn, it has a section about model persistence, and it says, hey, there's built-in support for Pickle. It has some issues. If you don't want to use Pickle, you're on your own. And that is pretty much, this is one of the hairiest things, actually. And this is something that, I'll talk a little bit later about what some larger companies do to solve this problem. But we are using Pickle. Issues with Pickle, if you aren't familiar with, so Pickle is a built-in Python library for taking a Python object and serializing it into something you can put in a file. Issues with it are, number one, it's code. And if you unpickle something, it gets a chance to just run arbitrary code. So you definitely don't, if your friend says, hey, I found this file, you want to unpickle it? Say no. Don't do it. So you want to trust where you get your pickle from before you unpickle it. It's in life. Whew. Well, this got exciting. In our case, we're using Pickle, and the place that we're doing this, we're all in Amazon Web Services, so S3 is the object store in AWS. So we're creating an S3 client. KMS is Amazon's key management service. So what we're doing here is we're dumping our pipeline object to a Pickle file. We're then encrypting that Pickle file, and we're putting that object to S3. Why are we encrypting it? Again, we're using this key management thing. This is to guarantee that it came from this service that has access to the key. Or whoever created this Pickle had access to the key, and hopefully it wasn't some rogue engineer that has access to many things. Hopefully it was actually the service. Yep. So that's what it looks like for us to turn this thing into a Pickle and put it in S3. And then our Flask app pulls the thing up when we start the app. That's what we decided. So we have no way of automatically doing that. If we want to change which model we're using, we change the config file and we restart the service in order to pull in that new updated model with more training data or with updated logic. That's one of the really nice things about the scikit-learn pipeline is it's packaging together all the logic of the pipeline along with the trained data. So you pull this out, you unencrypt it, and then you have it available to your app to use. Step 2 is provide an environment for doing this batch training and evaluation. I'm going to read through this quickly. This is something like the actual training of the model. Data scientists could do that on their laptop. In our case, it's not super computationally expensive. So you could just do that, create the thing, create your model there, and then have the data scientists put in S3. We want some more guardrails on that because, like, what if they pulled in some random version of something or whatever? So when we train the model, we want to know like what version of the code is used, what are all the libraries, really be able to reproduce this model if it came to it. You also might want to do really computationally expensive things when you're training the model. So something that we could do is there's this grid search thing. What this whole blob is just saying like, hey, our pipeline had all these parameters we were passing in. We don't know if those are the best parameters. Let's try out a whole bunch of different options, a bunch of different combinations, and like 5 times 3 times 3 times 2 times 2 times 2 is already 360 different combinations. Let's just run this whole process to fit the model on each one of those combinations. And that's where you start being like, well, it would be nice to have an environment to just do all of that stuff and not do it on my laptop. So that's something that you may want to consider. And step 3 is when you actually, you have your app running, how do you know if it's doing reasonable things? So you want to do kind of all the things that you would do with any other web service. You want to monitor performance. You have to figure out how you adapt to production load if there are there spikes. And when this happens, do we get pretty average consistent from the model, pretty average performance from the model, or does that vary a lot? How do you degrade gracefully if something goes terribly wrong? And other applications that are now relying on getting these predictions back don't get predictions back. And as I said at the beginning, I don't have a whole lot to say on this subject yet because we have not actually started relying on this yet. So we have a toy. We know that the general approach works, but we shall see how it goes when we actually get this into production and rely on it. So last thing I want to touch on is what are some other approaches if you don't want to put together your own batch process, figure out how you're going to do all the persistence and all of that. So considerations is how big is your team? For us, we have a team of 3 data engineers right now. We have a team of like half a dozen data scientists. But like all of us were kind of working on this part-time and took us kind of 3 months to build what we built. A lot of companies that really care about machine learning have a whole like team of machine learning engineers and stuff. And this starts to look very different in that case. If you're really big and you have lots of engineering resources to throw at it and you care a whole lot about the performance of the model, what a lot of people will do is sometimes actually train the model in scikit-learn or in Python. Data scientists are familiar with that. They can create this, some artifact. But you choose some custom serialization format, like you dump it out to some JSON with the parameters, and then you might have an application written in Java or Scala or something else to actually run the model and get better performance that way. And you've kind of defined your own interface to get from one language to the other, and that takes a whole lot more effort than what we threw at this. So how large of a problem space do you need to cover? If you do that sort of thing that I just said, of like defining your own custom serialization format between one and the other, you have to do that for every different kind of model that you want. So this is something where like right now, we don't know what all kinds of models we might want to use. So we wanted to focus on, let's try to do something that we could adapt to like other stuff in scikit-learn. And we might want to spin off some completely different model. So it's kind of nice that right now, we could do something that is significantly different from this natural language processing problem and throw it in there. So those are some of the considerations you might think about. There are also companies that would love to take your money. I don't know how legit any of these are, but these are some of the ones that I found. Yhat has a science ops platform. There's Anaconda Enterprise. There's Domino. They all have these nice shiny marketing materials, and they claim that they're gonna like solve your communication issues, and everybody's gonna be able to live in their happy land. And it's some variation of like, we'll provide infrastructure for you to like run this stuff. Your data scientists can like click on buttons and decide what version of a model is getting promoted. So it solves a bunch of those problems. We didn't go too far down the path of understanding that. All right, I am going to finish up here. You want to train, test in batch environments, even if you want to serve your results in real time. You have this nice concept of like serializing something and having this artifact of your trained model that you can then use in a different context. And Scikit-learn's pipeline module is really helpful for making that happen. And then actually serving a model in a real-time context. Once you figure the rest of this out, this looks a whole lot like just serving any other application, and likely the details of your own environment apply to that. So thank you. And we have approximately 8 minutes for questions. I am on Twitter at Jeff Klukas. I have already posted these slides, so you can see them on Twitter. I will try to remember to post them in Slack, or if somebody would like to go ahead and post that link in Slack, that would be good. What questions do you have? I have a question here.
Once it is in production, do you have any way of seeing from the results, of learning from the results of the thing, so that if, say, 95% of the queries are classified as customer education, you might be able to detect that there might be an issue with your training materials and so forth?
Yeah, our plan is to, first of all, we're going to be like logging all of these results to a database. Okay, yeah, I will repeat the question. So the question was, how will we know, basically, like as we're using this in production and we get answers out of it, how are we going to know like how well we're doing, and if it's way overclassifying things to one thing, how are we going to react to that? And we are planning to persist all of these classifications that happen to a database, so it'll be kind of a flexible data set that we can look at. Also, we're expecting if we classify things wrong, humans will still end up reclassifying them. So that'll be a very interesting thing to look at, is how many of these things get reclassified, and then it's to be seen like how much of that we feed back into the model and what exactly parameters we use to filter out what we train into new versions of the model.
So as you're prototyping it, running it, does it take a lot of resources at that stage?
So does this take a lot of resources while you're prototyping it? That probably depends on what you're doing, but in our case, it's the query to the database that's the expensive thing. So like I pull that in, and then I can pretty quickly iterate. Like training the model in this case, it's like it takes a second or two. But again, that very much depends on what algorithm you're using. There are all sorts of expensive classifiers and other processing that you can do on data.
So you mentioned that the engineers need to end up serving it up. Have you found good efficiencies or good optimizations? Because you just spun off with a class gap.
Mm-hmm.
More likely, different engineering groups are going to have their own different shipping codes and stuff.
Yep.
Have you found good optimizations for that, as far as that middle file?
Yeah, so the question is, what optimizations have we found? Like running a Flask gap, how does that perform? And we don't know at this point. We expect it to be like, it's a pretty low volume data set at this point. So we're not expecting to see performance issues, but it will be very interesting to see how we're able to handle it.
We tried putting the pickle file in the repo of the API for like GitHub. So if you're using like Docker or Kubernetes or something, when you're spinning up that image on every pull request to master, you have your pickle file in the repo, creates the image. And then if you're using Kubernetes and you have all your pods, you basically are scaling up to the sense that your users are going to different pods of the model at some point, which kind of a hacky way. I'm just curious of other implementations and that.
Yeah, there's not much we've learned yet in that area. Yep.
Your example, how many messages were in your training set?
How many messages were in our training set? I should have an answer for that. It's something on the order of like 100,000, I think. Over here.
If your data scientists were using a different tool like R or something, would that approach be something you could modify to accommodate that?
So yeah, if our data scientists were using something like R, would we be able to modify this approach? We kind of decided to go all in on Python. Of like most of our web services we create are in Scala. Spinning up a Flask app in Python is weird for us, so that's somewhat uncharted territory. But we decided like that's worth doing because it unlocks the whole Python data ecosystem, and we can just train the model in Python and then serve it in Python, and that gives us a lot of flexibility for right now. So the short answer is like we would also have to figure out how to serve an R model if we wanted to do that, and so that is not something we're planning to do. Yep.
I was wondering if you had any difficulties building like a batch of a training and analysis environment that you could actually get your data science team to decide on.
So, okay, did we have trouble building a batch training environment that we could actually get buy-in from? So we already happened to have a basically a scheduled task service running that happens to be in Python. It's using Celery to like basically be a really dumb and expensive cron solution. So that was something that was already existing. We're like, this is Python, we can throw Python code in here. So that's what we're using, and it was convenient for our particular situation. And our data scientists were already used to creating jobs in there. Yep.
I heard the term reinforcement learning. When you do go into production and try having your team reclassifying things, does that get into the realm of reinforcement learning?
So yeah, the question is when we have humans going in and reclassifying things, does that get into the realm of reinforcement learning if we're throwing that back into the model? I am not super familiar with the term reinforcement learning. Yeah, so I am not going to make a comment on that because I don't want to spread misinformation. But likely yes.
So if you have hard-coded models, you probably do things like, you could see like, please help me classify that as urgent, or you have some obvious rules. Have you seen examples of where you want to use machine learning to go past those obvious rules and find exceptions? Like if someone says, please help me learn about this new product. Have you seen examples of when it manages to find those exceptions?
So the question is about have you seen examples of where like you have kind of like a concept of please help, and is it able to find variants of that you weren't that a human wasn't anticipating? I don't not off the top of my head, but I mean if you play around with this, like yes, I mean that idea of like stemming words, like lemmatizing, all that, like it works pretty well. So it's something worth playing around with. All right, I will take one more question. Yep.
I know you mentioned this in the beginning of the talk, so I apologize if you have to reiterate.
Yep.
Well, what is the goal, I guess, of all this? So you already have human beings classifying information.
Yep.
What are you hoping to get out of having a machine do it?
Yeah, so we already have a process for humans classifying these chats. What's the benefit of having a machine do this? So it's two things. First of all, it's getting to that workload off of a human, so it's a human that can go do something else.
I'm sorry, the workload, though, is just like picking it from the drop-down button, right?
Yeah, so the workload is, the workload is reading through the message, understanding what it is, picking some category from a drop-down, and going through that. So it removes a human having to be dedicated to that task and being able to do what they are more talented at doing. It also reduces the amount of time to get to that classification. So even if you have like a triage system set up, maybe somebody's like going in once an hour and working down the list of new messages. And with this, it's, as soon as a message comes in, within seconds, it can have that first step of classification. So then people that are assigned to working urgent tickets, like those are immediately available in that queue. So we're hoping that it's going to bring down the mean time to resolution on those urgent issues. Thank you, everybody. I'm happy to answer in grad school. So huge data sets, no machine learning. Why? Some people did use machine learning in that realm, but it's kind of something you only resort to if you have to, because in research, like you want your results to be interpretable. You want to be able to explain what's going on. So I mean, I'm kind of proud of that we really did, I feel like, do a good job of relying on. If you can make a plot and say, I cut out everything below this line on this plot, that is understandable. And like those are the kinds of papers that we were writing. So lots of data, but making these very like interpretable things on top of it. With machine learning, you're kind of handing data over to a black box. And then you say, like, what did it do in that black box? And you can talk about algorithms, and you can talk about linear algebra, but there's a lot more context you need to know, and in the end, there are a lot of details that are harder to reproduce. So these are reasons why you might not want to use machine learning for a problem. And what I'm talking about today is going to be machine learning on a very small data set, which is a couple of gigabytes. This was big data, no machine learning. Today we're talking about machine learning without big data. And there are good reasons to do that or not to do that, and hopefully you'll leave this with a little bit better understanding of why you might want to or not use machine learning for your problem. So a bit of an overview of the story today. Talk more about the problem that we're solving. In our case, it's about classifying text chats. We'll talk about that question of why did we use machine learning for this problem? Why might we not want to use it for this problem? We will walk through steps of developing the model. So you'll get to actually see a bunch of Python code showing you what it looks like to interact with Scikit-learn. And it turns out that humans love live demos and seeing things actually happen. So you humans will be able to experience that rather than just seeing slides and believing me. Then we'll learn. There's some hype in there. So I will do a little bit of explaining about what machine learning is, if you're not familiar with that. Hopefully explain what it is and what it isn't. In production, that is slightly a lie. This talk is about a project that was supposed to be in production at this point in time when I committed to doing this several months ago. We've done a lot of the work to get it there, but take with a slight grain of salt in that I won't actually be able to talk about the learnings of, as this thing has scaled up so far. But we will be using Scikit-learn. I am a data engineer at Simple. I will tell you a little bit more about what Simple is. First, a little bit more background on me. I am Jeff Klukas. I came to technology through science. So I went to grad school at the University of Wisconsin-Madison. I worked on the Large Hadron Collider. Then we'll talk through some complications of this. Okay, so you've built this kind of toy model, you've proved that it can work, and then you actually want to run this thing in production and do useful things with it. And what gets complicated about that? How do you manage that whole life cycle of creating a model and using it? Then lastly, we'll talk about if you think that what we did in here is garbage, how else might you decide to do this if you want to do machine learning? And there are lots of different reasons why, like the shape of your organization and your team and your problem are likely not going to be exactly what is shown here. So other approaches might work for you. So what is the problem that we're solving? A little bit of context. This is simple. It's the whole idea of banking remade with lovely design, equally lovely tools to help you save right inside your account, and genuine human goodness. I'm going to actually be focusing on this genuine human goodness part, which largely talks about Glider, which is really fun. This is me in the cavern of the CMS experiment in Switzerland, about 100 meters underground. So why do I mention this? Since I now work at a tech company, I mention it probably because it's just cool. It was a fun. It was a pretty fun project to work on. I also mention it because when you think of machine learning, you often think of big data. And this was a project that was definitely big data. Like when this thing is running, there are collisions happening every 25 nanoseconds. Like each one's like a megabyte. It ends up being a huge amount of data. There's like all this cool trigger system to like get down to a manageable size, and you still end up with petabytes of data. So like petabytes, you have 1,000 gigabytes is a terabyte, 1,000 terabytes is a petabyte. Then you have like hundreds of petabytes of data sitting on a disk somewhere, and you're doing distributed stuff to process it. So I got to do that in grad school. Never once did I do any machine learning